Factoring trinomials. In order to begin factoring trinomials, let's dissect the multiplication of two binomials using the FOIL method. As you recall, the FOIL method means that we're taking two binomials and multiplying the first terms, the outside terms, the inside terms, and the last terms in order to ensure that everything in the first set of parentheses multiplies everything in the second set of parentheses. We get 4 terms when we do that, and collecting like terms, I get this middle term of 8x for this set of binomials. So looking in this process in reverse, we want to figure out how it is that we arrived at the trinomial's first term. The first term was the product of the first terms of each of the binomials. The second term is the product of the outside added to the product of the inside. And the third term, or our last, multiplied together, gives us the 15. So how do we arrive at this trinomial's first term? The same way, we get a 6x squared splitting this way. 11x outside and inside, and the 4 they've split up as 1 and 4. Is this placement unique when we have a trinomial that's factored this way? Well, let's see. If I had put instead a 2x plus 4 and a 3x plus 1, switching the place of my last terms, what would we get? We have a 2x times 3x is 6x squared. We have the outside is a 2x. We have the inside is a 12x. And the last is a 4. So when I collect my like terms, I have 6x squared plus 14x plus 4. And this is not what our trinomial was, so definitely the placement is unique. Why or why not? Well, we tried out moving those terms and it didn't end up to be the same trinomial. So this is the factorization for this trinomial. The same terms in the binomials, but in a different order, is going to produce a different trinomial for us. So how do we arrive at this trinomial's first term? Again, it's the product of the first. The second term is the outside and the inside added together. The third term is the last multiplied together. So here we have different signs. Is the sign placement unique? In other words, if I had a 5x and put the plus here and a 3x and put the minus here instead, would I come up with the same trinomial? Well, 5x times 3x is 15x squared. I have a negative 35x. I have a positive 6x. And I have a negative 14. When I combine like terms, I'll have 15x squared, negative 29x, and a negative 14. So the first and the last are the same, but I don't have the same for the middle. I have the same number, but not the same sign. So this is a different factorization for a different trinomial. So the sign placement definitely is unique. Here, if we have the factors in the same place, but we switch the signs, we'll get the same middle term, but a different sign, which means it's a different trinomial. How do we arrive at this trinomial's first term? Again, the first term comes from multiplying the first. The second term from the outside and then the inside, and then add them together. And then the last from multiplying those. So are there some combinations of factors that we could eliminate as a possibility? Apparently we're splitting 10x squared up as 2x and 5x. What if we had split it up instead as x and 10x? That would give us a 10x squared also, wouldn't it? So let's go ahead and try. If I make this an x minus 3 and a 10x minus 8, is this a possibility? If I multiply, I get my 10x squared for the first term. For the last, I get my positive 24. And for my middle, I'll have a negative 8x and a negative 30x in the middle. So when I add those together, I get a negative 38x, not what I wanted. So this is not the factorization of that trinomial. Now if we look at the trinomial that this factorization created, you'll notice something interesting. We have a common factor of 2. We don't have a greatest common factor here. So this is definitely not a factorization that we would consider viable. Also, if you look at this, there's a greatest common factor in this one factor. If there's not a greatest common factor in our original trinomial, there's not going to be a greatest common factor in one of our factors. So definitely, because of that reason, we would not even consider this factorization as a possibility. Let's say that we keep the 2x and the 5x split this way. And let's say both of their signs are still negative, but we split 24 up instead of 3 and 8 as 4 and 6. 4 times 6 is my 24, so that would be fine. But again, I have a greatest common factor in this one factor, so I would not consider that a possibility. I could also put a 2x minus